Last segment we saw about the definition and the meaning of a couple moment and how important it is. Okay. And then we also derived the formula through which we can easily calculate this couple moment in complex cases. And that formula was say C is equal to E crossed with F. Okay. Now, in this segment what we will see is what is the meaning of addition of two couple moments. Okay. I mean calculation wise or algebra wise it is not at all any difficult, it is as easy as adding any two vectors, component wise you can just add them. But there is something which is very interesting which happens behind the scene when you add actually two vectors, two couple moments. So, that is what we are going to discuss in this, and in deriving this or in visualizing this behind the scene things which are involved in addition of two couple moments, we will actually exemplify some more characters of this couple moment vector. If you remember, we discussed that it is a free vector. Okay. Now, if it is a free vector, and let me okay. So, we saw that suppose this is our axis, right, and let there be two equal and opposite vectors whose line of action are different and there is a distance d between them. Okay. Then let me also draw maybe the I'll show the try to show at least it is bad. Suppose this is the vector which we call C. I think the direction is wrong. Yep. So, sorry for that, because if you see the direction should be in this way, right, because if you draw this E, let us do that for a moment. So, E will be from somewhere here to somewhere here, maybe E, and I will write the F's also, F and minus F. Okay. And then if you turn E towards F, you will get a downward thing, and to visualize that as I mentioned last time, it is always good to have a plane drawn like that which can be assumed to contain these vectors, and then you can think that the moment C is perpendicular to this plane which contains these two. It is not necessary, but it is useful. Then let us see how and we can represent the direction along with the direction. So, now this C will be say I will try to draw inward basically. So, something like that. Okay. So, this is maybe C, which is actually pointing downward there. Okay. Now, always students face this problem of thinking that this C should be drawn just at the center of these two vectors, equidistant from both sides, like in a symmetric way. But that idea should first be removed. In fact, you can draw this C anywhere on the plane. Okay. I could have in fact draw here also, for example from here I could have drawn it, no probs, because this is a free vector, so it does not matter which point you apply this couple moment about, and it is the same, the effect is exactly the same. And what it conveys, another thing is that without affecting the system in any ways, you can shift basically these forces which constitute the couple. Okay, this is the couple moment, this is the couple. You can move the couple around on this plane basically, anywhere. So I am free to move this thing say to this point, maybe here, like that. Okay. I have tried not to change the length and the distance between them, and I have tried to keep them on the same plane. Okay. Now, and then that does not matter, because again this is a free vector. So that is one freedom which you get. Then second is, we can actually change the distance between them also by appropriately modifying the values of the forces, right. For example, suppose this is say d, the distance between them is d, and say the forces are F and minus F. If I reduce d to d dash, maybe, so let me do that. Suppose I change d to say here, I'll try to make it double the distance, maybe here, okay, and this distance being 2 times d. Okay. Suppose this becomes 2d, then I just need to change the value of f to f over 2, and then so here this forces I will just change to f over 2 and f minus f over 2, and then the magnitude and the direction for that matter will remain exactly the same. So f over 2 times 2d will give us just ft, right. So nothing has changed. So that means we have two kinds of freedom, that we can move the couple around on the same plane on which they are living, and we can change the separation between them by appropriately modifying their magnitudes. So that these are the two things which we will use to see the actual point which we had come here to see. That is what is the meaning of addition of two couple moments. Okay. Now for that, let us do one thing. Maybe, yeah. So let us see. I'll go to the next page because I'll need some space. Okay. Now let's assume that we have with an example we will see this. It will be easier to understand what we are doing. Suppose there is a cube like this. Okay. It's a cube, and on this top face we have say a set of forces which constitute a couple, say like this. So these two yellow forces, they are living on this plane, top plane. Okay, I'll say maybe plane A, and this I'll call, say I'll put a green vector there, and I'll call plane B. It's okay. Now, and assume that on this surface we have another couple which is say this and this, like that. Okay, and the forces here, let's assume here it's 5 units, say newtons, and 5 Newton this side, and here the forces are maybe 20 Newton and 20 Newton. Okay, and let the distance between those two forces be say 5 centimeters. Okay, and here also maybe 5 centimeters. Okay. Then what are the values of the couple moments which are existing on those two surfaces? The values are 20 times 5, right? So 100 Newton centimeter. Then let me draw this. So in which direction? Yeah, so this will be in this direction, right? So like that. So this C1 or top, C top is equal to 100 Newton centimeter. And similarly, what about this? This side it will be 5 into 5, 25, isn't it? Say now this one like that. It's bad drawing. Say this one. Okay. Now this one, I'll erase this thing so that it will be clearer. Similarly here. Okay. Okay. Yeah, I have come here, so I'll erase this also. I'll make it clear. Okay. Now, how much is that? This is around 25 Newton centimeter, right? Suppose we try to add them. It's as I had earlier told you that you can simply suppose this is x direction, y direction, z direction. You can represent them in terms of I and j's and all. You can just add them. That's easy. That's not a problem. We are trying to see what exactly does that mean conceptually, the addition. It's actually really interesting, and it will exemplify the two concepts which just now we discussed. Okay. Now we told that we can move this couple on this plane and this couple on this plane, right, on plane B. And in fact, you should always keep it in mind that this arrow is not fixed to this location, or this location, or this arrow is not fixed to this location. You can move it around basically anywhere. They are a free vector. Now, so I have many freedoms. I can move these couple around on this surface. I can rotate them. It doesn't matter. I can rotate this also on this. So let's do that. Okay. Now I'll go to say another picture where I'll try to do the same thing, but with rotated picture or couple moments. Okay. So yeah, still it's a bad drawing. So let me try again. Okay, now let's see. It's bad. Anyways, Okay, that's fine. So now what I would do is I would turn these vectors and I'll bring them around here. Let me do that. Say my yellow vector has come here like this. Okay, it's 20 Newton. Still the distance is say 5 unit, and I'll bring this vector here. So like the green vector, right? So I'll make this. So this is 5. I'll draw a bit shorter one to represent that it's 5, and on this side which direction basically it should be, let's check. I'll bring this to match on this edge, so it will be this one. Okay, let's first draw this. Okay, so this is 5 Newton and this is 5 Newton, right? Now I want these two forces to cancel out each other. So what I will do is I'll use the other freedom which just now I had discussed, that I can bring them closer and appropriately modify it to make it 4 times, so that, because this is 20 Newton, isn't it? This is 20 Newton, this is 5. So if I increase it 4 times, it will become 20 and it will cancel out each other, and in that process I will have to bring them closer. Okay, so let me do that. So I'll just erase this now and make it 20 Newton, 20 Newton, but the distance now has become, earlier it was 5, the distance has to be 1/4 of that. So 5 by 4 centimeters now, right? So this distance now has become 5 by 4 centimeters. So then what you can observe is these two forces which are sitting over here, they will just cancel each other out, and then what you will remain with is something like this. The last picture which will give us everything, say, okay, so let's see. Okay, now here what was there? So this force of 20 Newton and this force of 20 Newton, right? So I'll draw this yellow one at a distance of bad drawing. So 20 Newton at a distance of 5 units, and a green one in this direction 20 Newton, but a distance of this again is bad. I'll draw parallel to this. Okay, yeah, so 20 Newton, but this distance is 5 units. So this is 5 units, 5 centimeters, and this distance here is 5/4 centimeters. Okay, so that means if I have to say, I'll do one thing, I'll cut a segment like this from here, from the cube down. Okay, so like that. If I remove this and look from this side, what I will see is a cube like this maybe, okay, and like that, not that much of slope. So here and like that, and here, this is the face. This face, okay, I am looking at, and this force here is coming out. Let me draw the 3D only so that it will be easily visualized. Okay. Now the yellow force is here of 20 units and the green force is here with 20 Newton, and that is the plane on which this resultant added couple moment acts. So then you can think of the actual direction of the couple moment to be in this direction, right. So this will be C prime, which will be equal to suppose I call them whatever C1 and say C2 here, then this will be equal to C1 plus C2. So that's the behind the scene thing which actually happens when multiple couple forces are acting. In a way, we have seen a sort of resultant of all the forces which we are acting on various planes, and going ahead, in fact, we will be seeing more such situations where many more and much more complex systems of forces will be existing, and we will have to figure out what is their resultant. But this is the one which actually gives us an idea about the addition of couple moment, which I thought is a very interesting thing to actually understand and realize what is happening. And just before leaving this section, I want to make one point. Like any other vector, we can actually take a dot product. Suppose we have a couple moment C, okay, in any direction, maybe this, and then so that's over. This is another you can say another small topic which I just want to club with this addition thing. Okay, so that's done. That's done. So if you have a say a couple moment like that, and if you have say a line, something like that, A prime. Okay. Now the couple moments, if you try to find out about this A prime, you remember the way we did for the moment of a force about an axis. So similarly, the couple moment about an axis, if you want to try, because this is like couple moment about this point, and this point is moving anyways, but about this point, and now we are trying to figure out what is the couple moment C or effect of the couple moment about an axis. Then the same thing which we did for the moment should be done, and now suppose this is our vector n, which represents the unit vector in the direction of A prime. So you just have to do C dotted with n to get whatever we want to get. So this is in a way C about A prime, and it's again a magnitude, right, because you are taking a dot product, and the direction anyway is fixed in the direction of n prime. And if you are actually you want the vector form, so that will be C A prime vector will be C dotted with n times n. So that's the small additional thing which I thought is important, and in many cases it can be used directly. Okay, so that sort of finishes about all the important vectors which we need for our all the problem solving skills. So, I will just summarize once and for all. One is unit vector, second is position vector, third is displacement vector, okay. Then fourth is moment about a point, okay, moment of a force when I say moment. Then five, moment about an axis and the couple moment. So, these are the 6 vectors which you should be feeling very comfortable about. Then you are ready to solve any complicated problem which we will see, mainly of equilibrium and in fact a lot of types of problems which you will be able to solve once you are very comfortable with these 6. So, please go through them and then make yourself comfortable with them, and then we will see in the next segment about something called force systems. Okay, when multiple of such things act on a particular body, what happens, how to think about them. See you then.